Okay, I think we can start. Right. So, this second talk, some people were asking me, like, what are you actually going to talk about? And I am going to talk about getters and setters. Sound kind of boring, but I promise you, they are awesome. And the first time I opened my eyes to this topic was with the talk that Eric Meyer did, where he showed, getters and setters. And he showed that a setter is like an observable. It was awesome. So I might quote that talk sometimes today. And I'm going to show how they're useful and how you see them everywhere in code. So I'm going to code a little bit and kind of show how they're everywhere. And then you're going to see why are they useful, how can you use them, sort of like a little bit opening mind type of thing. Yeah. So let's say you have a very simple JavaScript program. Is this font size okay? Yeah. Okay, so you have X is a number and Y is a string, Z is a boolean. Imagine that you're learning JavaScript for the first time. You probably did something like this. But these kind of programs are very useless. I mean, you run it and it's like nothing happens. Absolutely useless. No point in doing this. So when you're teaching programming language to someone, how many of you are fathers? It's a good number of fathers, right? So if you teach programming, yeah, mothers are fathers. Their kids may ask you at some point in their life, like, Father, where does data come from? And then you're very awkward, oh, I need to tell them how it actually goes. And then when they grow a little bit more, they may ask you, Daddy, where does data go? And then you're like, oh man, I don't even know this answer myself. So then you're like, yeah, whatever, let's just skip that. So, but then when you're learning JavaScript, you know, okay, in order to make this program useful, I need to do something like this, right? And then it's like, wow, now it's useful, this program does something, it's usable, and blah, blah. And we were only able to do that because of this magical function that it takes a t and returns nothing, where t here, is a string. But in the general case, it's a function that takes something and it just, yeah, that's it. And that's awesome. It's built in the language. It's built in. And it makes you do stuff. I mean, you can do stuff. But sure, this program is quite boring because it always outputs iterators. I'm trying to pronounce it. And so let's do something a bit more useful, right? How can I get data into my program? Well, here's another way, a very simple way. Let's say I want, what's the time right now? I say date now. And then you get that date thing there. It's like milliseconds since 1970s. And wow, now this is a much more useful program because I get a different number every time and it tells me something. And what is the type of this method? I give it nothing and it gives me something. That's awesome. It's like a fountain of data. And that's awesome. But that's where data comes from. Now you can answer your kid. Date.now. There's also a bunch of others like, let's say, math.random, right? You give it nothing, and it's like random numbers just coming out. And this is built-in. It's built in there. Yeah, it's there. So, but still, this program is kind of useless because all that I did was I just got data from the system and I put data back in the system. So the way that we program is that we usually create some intermediate stuff here, like let's say I get that amount of milliseconds divided by 1,000. So now I have seconds. And then if I divide it by 60, I get minutes. And divided by 60 again, I get hours. And divided by 24, I guess, if I'm correct. And then you get years. And then you can, I'll put that for years. You get 47 and a half. So if you're 47 years old, we know that you were born in 1970s. And so forth. So you can do nice calculations here in the middle between that getting and that setting. So it turns out that these stuff things that look like this in JavaScript and things that look like this are fundamental. We need them. Without them, we would make no programs. See, that's the beginning of the beauty of this thing, because we need them. They mean I/O, input, output. So that's how we get stuff in and how we get stuff out. And in a more subtle level, we have also, getters that you haven't actually acknowledged that they're getters. For instance, I can call this variable O1, and I can say like that. And I can do this. And then, if you console log O1 and you check, is it the same as O2? And you run it, it says, no, it's not the same. So this means that this is now a fountain of objects. Whenever I do this, it's like, new object out of no, new object, right? And it's a different object every time I call it. It's not a function, right? It's not actually a function that you do this. Maybe if JavaScript had a built-in that was like object dot create. Oh, it does have. I didn't plan for this actually. It's not. Anyway, yeah, okay. Let's see. So, you can continue this exercise and check all of the functions in JavaScript that look like that and T and T to nothing. And you're going to find many of them, and they are useful. So, I'm going to give them some names. I'm going to write a little bit of TypeScript just because I want to give these stuff some name. A getter is a function that takes nothing and returns to me a T, a getter of type T. And so then, let's say math.random is, well, you can, let's just say F. F is a getter of numbers, and F is math.random. That will fulfill, okay? I'm just giving names to stuff. And then setter is a function that takes T and returns nothing. This syntax doesn't really work in TypeScript. We just need to write it slightly differently. And empty parentheses doesn't work in TypeScript, but it's the same idea here. The idea being that we take T and we return nothing, or nothing is void. Okay, let me actually, yeah, so what if I would do this? I would create a type called function from A to B, which is at the same time a setter of A and a getter of B. You see? Because, if it's that case, then it's like, you set A and you get nothing, but you also get B. Kind of know what I mean? On the other hand, this is tricky to do. I can't really say this, and I can show you why I can't say this. I'm just going to make a function that's, let's say this is the function from number to strings. And then I give, X is a number, and then I just, put that in a string. This doesn't really fulfill this thing, and that's because TypeScript is confused. Are you talking about A to B, or are you talking about nothing to nothing, right? Because if you try to do the intersection with this and that, it's kind of confused. Like, what do you mean? Do you mean this and this, or do you mean this and this, right? It's sort of confused. So that's why I'm not going to talk about getter as a function. Okay, that's one of the options, is to define function first. Can you see this? It's fn. And then after that, you define a getter as, let's say, a special case of function that doesn't take an argument. Okay? And then you can say that a setter is a special case of a function. I'm not going to say that. I'm going to say something else. I want to put this getter and setter in like heaven. So I'm going to define a getter as a fundamental thing. And as a notation, I'm not going to use the arrow. I'm going to use, it's like down T. Why am I doing that? I'm just saying this is a way that you can download T. Okay, you can get T. Download T. not a function. It's just a way of getting t. And in the case of the object, right, when you say const obj is that, you see there's no function here going on. It's just a way that you can download an object. Forget about object create. Okay. Anyway, forget about that one. So it's a way of downloading data, and then we have setter, which is a way of uploading t, right? Because that's what we're doing when we do console log. We're saying, I'm uploading the string for you to put on the console, right? And when you're using data, now you're downloading data, the data now. And then, contrary to, here, we're sort of defining getter and setter as a special type of functions. I'm going to define a function as a special type of thing, which is at the same time is a downloader and an uploader of data. It makes sense. I mean, when you call a function, you're sort of uploading data to it, and you're expecting back some data to be dumped down to you, right? Request and response. So just allow me to do that sort of definition, because then I put getters and setters at very special stuff. So I'm going to be able to write this f function just by doing this type of thing. I say whatever, I don't care, to whatever, I don't care. It's kind of as if I'm saying, a getter is I don't care to something because I don't download data, and a setter is I put it and I don't care about what comes out. Anyway, then once you say this, TypeScript is able to let this pass, and it knows that you're talking about this and not empty. And that's also a cool thing, is that what is this thing then? This thing, what is that? You have some of these functions. What would be a good example? Start, right? It usually has no arguments, and it's just start. You also have stop, right? It usually just like stop. You also have toggle. Any other ideas? Because basically what this function represents is, that's the only thing it says. It doesn't say anything. I'm going to call it as a special case of a setter, because you're telling something else. That's what you're saying, okay? This is a special case of the setter. I'm just going to put it here in the corner. Blah, 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 blah. This little no-op thing is a special case of a setter. Okay, I'm going to get to an interesting point at some point. Oh gosh. Yeah, okay, so admire that. A function is a getter setter. What next? There are different ways of getting data in JavaScript, right? We saw it this way, and that's kind of boring because, this is not how most of the JavaScript programs run, because here, you run it and it's done, and it's done, right? It goes from line 5 to 6 to 7, and it stops. JavaScript has much more than that, right? It has, what's the other way of getting data? Huh? The user? How do you get data from the user? Huh? Event listener? What's that? What's an event listener?
Input stream?
What's an event listener? Callbacks. Why am I showing this now? Oh no. Yeah, callbacks. I'm going to talk about the covariance stuff a little bit sooner. But callbacks, look at that. Here I have this special built-in function where I can put a function. Okay, and this function is like, let's look at this carefully. Okay, add event listener. It takes. Oh gosh, what add event listener? Yeah, it takes a string and it takes this callback. What's the type of that? It's event to nothing, right? Or void. Right, so it's basically, here I want a setter event. Okay? And what is this? there are many cases of different types of APIs for add event listener that they just don't return anything, because then you have remove event listener. And if you would like simplify this to be set click listener, right? Then you don't need to specify the event type click, so you can just say CB, and this is a setter of event, right? And what's the type of set click listener? It's a setter of CBs, right? And what is a CB? It's a setter of event, right? So set click listener is a setter of setter. That's pretty awesome, because with getters you can read data, right? With setters you can write data. With setters you can read data. It's kind of odd, right? You write, read. That's kind of funny. But it makes sense when you think of it as uploading. So basically, I am uploading this uploader, right? So then the thing that receives your uploader will upload to you, right? So that's how you can get data back. That's how you can read data. Now this is powerful because it provides us asynchronous programming, and we didn't have that before. Yeah. Let me show you a slide from Eric Meyer from his talk that inspired me. And he talked about this stuff. He said, you know, getters are covariant. What is that? Here, imagine that A is a subtype of B. Let's say cats are a subtype of, cats are a subtype of animal. Where should I draw this? Maybe I should draw it here. If cats are a subtype of animals, then a getter of cats is a getter of animals, right? It's basically a way of getting cats will surely be a way of getting animals, because every cat is an animal. Yeah. But then what happens with setters? And this is the thing that's pretty confusing to understand, and it's hard. It's not that easy. But in the case that, okay, cats are a subset of animals, a setter of animals is a subtype of a setter of cat. And that sounds odd, but I can give you an example. Let's say I have a way of feeding animals, okay? You give me an animal, I will feed them, okay? So the type would be there, you know, function feed, and it accepts an animal. And I will just return nothing because I just fed the animal, and that's it, right? If we have this thing, then, you know, it means that I know how to feed animals. So a cat is an animal. I know how to feed the cat. So that means that this is okay every time I want a feed of cats. Trust me, this is true. If you don't get it, it is true. It just takes a little bit of alcohol to get it. Yeah, but this is important because what Eric Meyer says is that once you have a setter, they become covariant. They become covariant, not contravariant. What does that mean? That means that setter of cat is a subtype of setter of animal. So that's where things swap around. So you sort of like swap it twice and you get that. Why is this true? Because let's say, why is this true?
Is the setter together?
Because that's an animal.
This is complicated. Yeah, we can do this a bit more interactively, but yeah, this is true. Basically, these are observables, and I'm going to talk about them soon. So I'm going to come back to this. I don't want to rush myself. Okay, but just admire for now that we have a way of getting data from setters. That's pretty cool. So let me write down an interesting matrix. Not here, but probably here. So, it's pretty interesting, right? If we go up one level of setter, we get one thing. If we go up 2 levels, we get like asynchronous callbacks and reads. That's awesome. So, what really happens once you go up 1 level, okay? When you think of, you go 1 level up with a getter, what do you achieve? You achieve reads. Okay? You go 1 level up with a setter, and that just means that you have a setter, okay? Then you can do writes. If you have a level 2 getter, which is a getter of getters, you can read. It performs read. We're going to see an example of that. But if you have 2 levels of setters, you can suddenly read. And that sounds quite odd, right? If you can't read the text, this is read, write, read, and read. Sounds like asymmetric and sort of weird. Something odd is going on here. Let's see how and why. Let's go back to this one. I'm just going to stick to this part now. So let's start with getters, basic getters, okay? I have a number x, and I have a getter of x, okay? What's the point? Well, I can console log out the x, and that will tell me, 10, or I can console log get x, and it will also tell me 10. Okay, what's the point of doing? Well, what happens when you do a getter is that, you will return 10, but now you have some space here for doing stuff in the middle of this function. Right? I can say console log hi, and then every time I try to read x, it says hi. You can do that. So that means that we gain side effects. Can I write that down somewhere? What the hell? It's black. So once we use a getter, we can add side effects. Side effects to it if we want. What else do we gain? We gain flexibility because I can return 10, but I can also return other stuff. I can do something like if math. Okay, imagine that I have this function here, and it's pretty boring, right? Every time I call it, it gives me 10, 10, 10, 10. What if you just want to surprise your co-workers? So you do something like math, random, and if it's like bigger than 9, then return, else return 10. So now I gain flexibility because every time my coworkers are like, what the happened there? Because it's like always 10, except sometimes it's 200, 2008. Anyway, the point being is that you gain flexibility. Now you can return 10 or you can return something else depending on some conditions. You are able to basically change what this number 10 is. It sort of represents 10, it's like with flexibility. So we gain flexibility, and with more examples, this is going to become more clear exactly how can we get flexibility. Yeah, and the other thing that we get is laziness, right? What if I have here a formula, which is 4 times 8? How much is that? Sorry, divided by 2. So, I'm doing this computation, but I'm not doing it as soon as possible. I could have done it like here, let's say, here, but then it means that it does it at that moment. It's quite hard to come up with an example where things would be computationally expensive, but imagine cryptography or something like that. You don't want to run that here, because then you're running it on the startup of the script, but instead you can run them there so that you run it whenever you need it, or on the right moment or something like that, right? That's what we gain here. We gain laziness plus laziness. So that's interesting. And one of the cool applications of this is that you can write, let's say, let me just move this back to 10. can write the function add for numbers like x and y, and you're going to return x and y. That's just a way of wrapping the operator plus. Or you can write get x and get y, and this will return to you a get c. So it's a getter, and here you can actually ask for those x and y, get y, and you can return x plus y. So now, if I could do something like, 10 plus random, and that would be add get x and add math random, right? And guess what happens once I do console log 10 plus random? It tells me function, right? So that means that it didn't actually calculate this thing. Once I called add, it didn't calculate that. What it gave me was this abstract idea of 10 plus random, which I can make it concrete by saying, please, I want that number right now. And then it gives you that number. And it represents 10 plus random, right? Maybe useful. So that's pretty cool. You could actually do a lot of math on the level of getters and not on the level of numbers, right? We're starting to get to somewhere. This is pretty cool. So what else? So if you go up one level in getters, you get these three things. What happens if you go 2 levels up? If you're a getter of getter. Let's see. Well, you could write add for getters, and then it just looks a bit more convoluted. And you're like, why are you doing this to me, Andre? I want something useful that I can use at work, not this. Well, just a second. Let's play around. I'm going to, let's say you have a getter, okay? Like an array getter. Getter. Just a second. This will make sense, I promise to you. I take an array and I will return a getter for that array. Okay, so no, sorry. Let me rather type here. I give an array and it gives me a getter of number. Let me cheat. Let me check what I did. Yeah, that's what I did. Sorry. Yeah. Let me just call this get array getter. Oh, there we go. I get what? An array getter. Okay. So I'm going to write that here. So what I'm going to do is I'm going to have a variable here to be the index, and then I'm going to return array of that index. And then after I return that, I'm also going to increment it. So how can you use this? You can say, here's my array getter for the array, let's say 10, 20, 30, 40, just for a second. And then I do console log array getter, get it once, get it twice, 3 times, 4 times. And then once I run blank, I get those numbers. Okay. See, it's a way of getting numbers from an array. Wow. So, why am I doing this? Check this. I'm going to create a function called start with that will take getter A and an initial number. Okay. I'm actually going to call this getter. We don't have another getter. But the idea is that here, what I'm going to get as an output is a getter. Okay? So let's just write outputs getter. Stay with me, this will make a lot of sense. So we know that this is a getter that returns a getter. Okay, because we know it's just 2 levels of getters. But I'm going to, this will actually give us the numbers. So I know that I should return some kind of numbers from here, right? but I want the first number to be this initial number. How do I know about the initial number? Is that I can make a boolean here called initial sent, and initially it's false. And then once I ask for a real number, I mean a concrete number, I'm going to check if the initial was sent, then I'm going to just return, I'm sorry, I need to get the getter. Stay with me. G, I'm going to call it G. I'm going to call the getter. Now I have G. So then I say G and pass it out. Other than that, I'm going to return what? The initial number. Right? Oops. Yeah. I guess I'm going to do that. Well, I'll simplify this for now. But anyway, this returns a getter. So it looks like this. It's a getter of numbers. Okay, now let me get to the nice part. See this array getter? What does it do? It gets numbers from the array. I am going to say nice getter is start with the number 5 before you do the array getter. So now if I use nice getter and I call it 4 times, it will tell yeah, this is a getter. You see, these things can get complicated, but they're going to get simpler, I promise you. Yeah, I'm just going to make this a getter, not a getter. But you can make it a getter, and there are reasons why to make it a getter, which I'll explain soon. Oops, I forgot to do initial sent is true. Okay? Didn't see that. So, see, now I am prepending the number 5 to this array. But I did that on an abstract level. I didn't actually put a number before in this array. But what does that have to do with getters? Because we're just doing normal getters. And that's why, and the reason why is because, is this microphone bad? Or, I don't know.
Yeah.
The reason why is that this boolean cannot be reset, right? We are sort of stuck to this boolean being what it is always. So if you try to call, nice get, if you want to replicate this, if you want to iterate over the array again, you don't have that chance, right? Because let's say if I keep on calling this, it's just going to say undefined. And how do I go back? What if I want to do 5, 10, 20, 30, 40 again? Okay? Yeah, we could try switch. So it may be hard if I'm like coding. No, that's not going to work. Yeah? Okay, well, let's go with this. So this is the reason why we're going to use getters, is that we can go back and start this all over again. So I'm just going to reintroduce this is now getter. Once I, yeah. Put that in the middle. And here I'm going to ask for my real first order getter, and then I can call it like that, okay? So now, this returns a getter of numbers, and this, this should be a getter as well, so that means I'm just going to wrap it, okay? Doesn't hurt. Cool. And now this getter. once I do this, yeah, start with works with getters. So then I will get out a getter. And now I can make nice getter is nice getter. And actually ask you for it, and then it gives me that. Let's see if it works. What did I do wrong? Nice getter is returning. This is the getter. Oh, it actually tells me the getter types. That's nice. Yeah. This is yeah. What should I call this? This should be yeah. Anyone see a problem? Why am I missing it? Let me go back to my code sample that worked. Yeah. So, yeah. Right, okay. Here's the idea. This is actually a getter. Because we say get a getter, right? So that's a power. In JavaScript, we actually have getters, and they're called iterators. And this is how things get more clear. Here is an iterator, the so-called ES6 iterator. So I have an object, and one of the properties of an object is a function that takes no arguments and returns me something, right? This is an object, but one of its fields is a getter, right? You give it no arguments, and it gives you stuff. With the iterators in JavaScript, you basically have these other parts, next and done and that kind of thing, so that you don't get this situation where you call the getter many times and then after that you just get undefined. So what iterators add is that they're basically getters, but they add also a completion point, so that you can safely know that this array didn't have a field that was undefined, but this array actually completed. And once you have that, you can concatenate it with other stuff. And this is something that's now native in JavaScript. And then you can use a nice syntax that looks like this. You can say for let of range, console log out that. So let's try running that. 0, 7, and you see 1 until 10. And it's important that we're using getters and not simple getters, because then you can repeat this for loop, and what's going to happen is that you're going to see 1 until 10 and 1 until 10. And that's not possible if you have only order 1 of getters. Okay? So I'm getting to something practical here, because you can actually use the syntax in JavaScript today, and it's all based on the idea of a getter. And why would you do that? Is that, check this, we don't actually have an array that has all those numbers, right? We have an abstract idea of an array of numbers 1 until 10. And this is starting to look a bit like what I said in the previous talk with Haskell, that you can represent an infinite list. You can also represent infinite lists in JavaScript. You could have, instead of the range iterator, you could have the integers iterator, and then it just keeps on going forever. And then you can have another function that takes this getter and will limit that to a specific amount of numbers, so that you're not picking all of the numbers forever. That would actually be interesting if we try this. Let's just give all the numbers forever. Range. Sorry. Yeah. Range. Who knows what's going to happen? Yep, there you go. Now I have represented the idea of infinite numbers, and I don't have them stored as an array, but I am lazily creating them on the fly. So all of this was possible because I got laziness and flexibility to do infinite stuff, right? Abstract stuff. All of this was from getters. So, if you add one level of getter, you get these 3. But also if you have 2 levels of getter, then you just have these 3 again. You have flexibility to choose what is the getter. You have side effect that you can add before downloading that getter. You see? Instead of a value, and you have laziness to create that getter. And this is the getter in that case. I'm not going to go to getter, getter, getters, okay? Relax. But it's helpful to put this in mind, that what they call iterable is a getter of getters of stuff. Okay, that's what an iterable is. And it's actually a real type. I think if you write in TypeScript, let's see, iterable. I probably need to download the types of ES6, but it's there. Trust me, it's there. So that's what a getter is. Well, roughly, because it also has these ideas of done, right? So it has this contract for, how to deal with these stuff. A getter is much simpler than an iterable. So I'll just write this like approximately, okay? And an iterator is just a getter of t. So this thing here was the iterator, right? That's what this function does. It's basically like, hey, can you lazily give me the iterator, which is this thing? Give me the next, give me the next, give me the next. So we could actually write an iterable is just a way of getting an iterator. Okay? So every time you see iterable, you think, it's a getter. And an iterator, it's a getter. Okay, cool. Now, let's see what happens if you go to basic setters, okay? Now this is comfort zone, because console log, it's a very simple setter. What do you gain with that? You gain output, right? You can make stuff. So it seems like with setters, the property that you get is just outputs, but only if it's built in, if it's a built-in function, okay? Like this is a built-in function, that's a built-in function, that is a built-in function. What if I just write my own setter here? How can I make this useful? And here's the point. I can only make this useful by using a built-in setter, like let's say wrapping it or something. This function here that I just wrote, exactly how it is, it's completely useless. It's like a black hole of data. You put data there and that's it. It's like a black hole. So if we go one level up with, one level of setter, you just gain nothing. It's like a black hole. Unless it's a built-in function. Okay? And that's odd. It's like, it's kind of sad. Right? With getters, you gain all this stuff, and with one level of setter, it's just a black hole, unless it's a built-in. But what happens if you have two levels of setters? Then you can allow stuff like this, and that's awesome, because then you gain asynchronous programming, which is huge, and it's super important. So I don't know how that can be, but if you have two black holes, you get asynchronous programming. It's sort of awesome, and I hope you appreciate it as much as I do. So this is a setter, and it's useful. You can create your own setters, like let's say, I'll create this one, like push array. Here I will set, I'll just call it, listen to array, maybe, that's better. Any array, okay? And I'm just gonna give it a listener, which you know what kind of function it is. And what I'm gonna do is I'm gonna say, okay, this array has all of this stuff. I am going to basically do, let's say, a for loop, I could do a more fancy for loop, but I'll do this type for loop. Just call this my array length. And then I will say, listener, here you go. Right? So there I have, this is a setter of a setter, right? And it's useful. Now I can say, listen to array. And here I'm going to give a setter, right? This is a setter. We know it's a setter. And I'm setting that setter. I might need to bind that, but just let's see. Oh, document right? Because we're Node. There we go. I can now read data, right? And I can put it from there. So that's cool. And apparently, this is not asynchronous programming. It's not asynchronous programming. It's actually completely synchronous. If you put these two console logs before and after, you're going to see that. So you don't just gain asynchronous programming, but you also gain reads, which is, with the setter, you gain reads. Yeah, that thing that I said earlier. That's cool, okay. And you can also do pretty interesting stuff with setters. So, like here, I'll just write the type of this number, right? You can create like a map function, just like you could create with, like, let's say, any kind of arrays. Here I will get a setter and a transform function. And I will return a setter somehow. So for instance, I'm going to write it similarly. Listen to transformed thing. And I will have a listener here. So what I need to do is I need to call the setter with a setter, right? Setter. So I'm going to get the data, and I'm going to pass it through the transform function. You could write this in a nicer way, but I'm just making it quite explicit. And then I'm going to call this listener here and say, here you go, that's Y. So then you could say, actually I will listen to tiny numbers is listen to array, but I'm going to map that with get that and multiply it by this very small numbers. And then I can listen to tiny numbers maybe. And there we go, I can listen to tiny numbers. So this is starting to be cool because now I can have functions that sort of transform these stuff. And this is basically the idea of an observable. Okay, but just like the iterable, what did we add with the iterable? We added the idea of this is complete, right? Because that allows us to concatenate stuff. Also here we're going to add the idea of complete, but we should just remove these. What is the subscribe function? It's a way of setting a setter. It's just a setter, okay? But it has also these other stuff in case you want to handle completion. Completion may be quite useful if you want to do something like, take the first 10 clicks only, or stuff like that. And not just completion, but we also have errors. If an error, as you know, typically this is something that happens in Node.js. It's written the other way around, but it's like error and CB, right? But actually the error there is an object or the actual error. Here, this is an error callback, because all of these things are setters. So every time you hear setter, just think callback, right? This is one way of thinking about it. But this is useful because then I can propagate errors between setters. So every time I talk about observable of T, it's roughly the idea of setter, but it just has error and completion added to it. Okay? So that's cool. We have now a class of pretty crazy stuff. We have getter, which is a special type of this. We have setters. And we know that these things are pretty useful. With this, you can create lazy collections that are not stored automatically, like the iterator. You can create Fibonacci numbers pretty nicely with this. With this, we get asynchronous programming. And what else? We can mix these things as well. We can have all sorts of stuff, like, let's say, we can have a getter of setters. And what is that? It's basically, as you see, this thing, I'm just going to call it a getter of observable, of key. Okay? What do we gain by doing this? Flexibility, laziness, and side effects. And this is a real thing because there's an operator in Rx called defer. And that's what it does, because there you go, you have a getter of, so this function, can I hover over it? And it doesn't tell me the type. Does it? It doesn't tell me the type, but you can see the type here. I give it nothing, and it gives me an observable. That's what we have. We have a getter of set of centers. Okay? What do I gain with this is that this observable, when I subscribe to it, it may either give me a clock, or it may give me clicks at random. So I gained the side effect of randomness. I gained the flexibility of choosing which observable under the hood do I want. And laziness, because this observable will be created on the fly. If you look at why is defer useful, there's actually nice blog posts explaining why defer is useful. This one is in Java, RxJava. And they say there, we want to, let's say, write some stuff to disk once we create the observable, a side effect. And it's pretty useful. It's very handy. So every time you feel like, I wish I could add a side effect for this observable, and then you have to put a getter there somehow. So that was getter of set of setters, which is a special type of this. No, it's a special type of getter. Anyway, you have GSS, a getter of setter of setters. And then what else? We could have maybe, what is a setter of a setter of setters? It's getting hard, but it's very basic. It's just, these lines here. As I said, it's kind of a setter of an observable of stuff. Okay, there's an actual API that looks like this, because it allows you to pass to another subsystem. You can say, hey, here are a stream of a bunch of messages that I'm going to pass to you. It's pretty useful. There's a database called Horizon, which is based on DB, I think. And they have a lot of APIs based on RxJS. One of them is, I guess, like aggregate. So it's a function that you can call, and one of these arguments can be an observable. So you're basically passing an observable to the subsystem, and you're saying like, hey, please aggregate on every 100 milliseconds, 1,000 milliseconds. So it's a way of passing a bunch of messages over time. It's useful, setting that. And it's useful in a real database. And you can go crazy with these, mixing all of these things. But the point here, and this is how you can apply it, is whenever you need these, you know that you just need to have a getter. And if you want asynchronous programming, if you're handling with asynchronous programming, you should have a setter somewhere. And this is why observables are not like a weird abstraction on top of stuff. They are literally just the idea of callbacks with error and completion handling embedded into them. So they're like, this is a very natural abstraction. You can find it in almost all the languages. But if you do it twice and you add error and completion, then you get observable. So we're not actually making things very weird. There are a couple of other stuff, like let's say, what if you would do like a getter of setters of stuff? That is, that's like the case where, let me get something clean here. It's like a function that you call and you get out a setter. So it's like T or something. So one of these functions that you find pretty often is like array pop. Oh, sorry. That's tricky. I mean, let's just make an array here, 10, 20, 30. And then if you say array.pop, you give it no argument and it will give you this thing, which in this case is a number. But what if these things would be functions, right? Let's say like, let's say x, and then like something, it takes something and does something else, and this one takes something and does something else. These represent pieces of work that you should do, right? So this is actually a queue of tasks. And there, when you pop from the queue of tasks, you get out a task. And then you can perform that task. So by having this structure of getter, of setters, you will be able to implement like a scheduler, and these things exist quite frequently. Like, for instance, the RxJS scheduler depends on these ideas. There you say, set this setter. And that's like a callback, but it also means that internally, when it wants to get all of that work, it will just pop it from the array and execute that work. So these things are everywhere. Yeah, another example? I think that's it. So it would seem like, and also IXJS is basically RxJS, but for iterables, for this side here. IXJS is pretty cool as well. But this makes you think, okay, so all of the languages have built-in setters and getters, right? Like Clojure has it, even Haskell, if you think of the IO monad, you can just get random numbers. They have those things there. So probably all of the languages have these two basic abstractions for input and output. Almost true. Almost all of the languages have, but not all of the languages do. In the first version of Haskell, they didn't have basic getters, a fountain of data. Didn't have that. What they had was this weird thing called stream.io, where they abstracted this part away. They said, you know what, we're not going to allow you to do this. You can only do this. That's what they had, lists. They had only this, seriously. Because this is a way of doing side effects, if you call it explicitly, right? Immediately. Over time, they decided to not use stream.io. But that's also the idea of this framework that I've been building, Psycho.js, where you're not allowed to do directly getters and setters because those are side effects. But instead, it's basically this idea here, where here is an observable, okay, a stream of messages, and I create another observable, a stream of messages, because I can read from the outside world with setter, right, observables. And then I can pipe those down as a chain of callbacks, and then I can pass my observable or setter to a subsystem, and that subsystem will execute those messages. And here we don't allow these two. We don't let those happen. We only allow actually setters. We don't have anything else than that. We don't have this yet. We might have it in the future. There's some good use cases we found for this. For instance, UUID, whenever you call, UUID, you pass it no arguments, and it gives you a unique identifier. That's a useful thing to have in a program, but that's the approach that we decided. Like, what if you don't allow any of these? We only have this, and then you can do almost anything more. You can read data, you can write data, and it's very flexible. So what I want you to get out of this is basically, if you're looking for some certain properties, you know that you're going to find them in those. And every time you look at your code, you can now start looking for these getters and look for these setters. And you will see where data is coming from and where data is going. And you can sort of have a bit more control over how I/O is happening in that. Okay, thank you, and I hope you don't go to sleep tonight thinking, oh, get it. But this is pretty cool stuff. If you didn't understand it, watch also Eric Meyer's talk. It's also amazing. Also on these lines, but slightly different. Okay, thank you.
Thank you very much. Well, are there any questions still? Wow. No one? I was wondering if you ever heard of the Dutch singer Anouk, because she wrote the song To Get Her Together. I thought it's a great addition to Somewhere Put It In.
Yeah.
But now you had some time to think, nobody... No questions?
Well, I go on. So,
Yeah.
did you actually get around to explaining why the setters are covariant?
Oh yeah, Let's try that. Why are they covariant is tricky. I don't think I can. Like in the talk that Eric Meyer gave, he just said that, you know, this is something that you're going to understand after some alcohol. And I don't drink alcohol. So. Yeah, but I can understand it on an intuitive level, and that's because I said I would introduce observables. So let's say, you know, I have an observable of mouse events, and then like my subsystem is expecting observable of events. So sure, I can pass an observable of mouse events. If something is expecting a stream of events, I can pass it a stream of mouse events, right? Because and I think this is about reads, right? Because setters allow you to have reads. So then it starts having the effects of the read side, like the getters. Because in getters, everything is covariant always, and it's nice. Probably because it's about reads. And this is a little bit related to other languages like Kotlin. I think also C#, but I'm not familiar with C#, where they say in the generic, you can say this is an in or an out in order to hint for the covariance or contravariance there. Anyway, I think that's in and out related read and write, so probably
makes
the
sense.
Make sense?
Yeah.
Thanks.
Thanks.
Oof, I did it. Any other question?
Yes.
Sure, this is a question.
So you have the combination of the getter and setter, which is a function. What would be the combination of the getter, setter, setter?
I just say that slow. Combination of.
So when I look at the diagram there, the obvious question would be what is the combination of the getter and the setter, setter? So what implements both those types?
Yeah. What would be basically the question is what would be an iterable and at the same time an observable?
Or doesn't it make sense? That's also possible.
It's kind of hard to say because in many of these cases where I said that this is just a getter, actually it is a function. So for instance, subscribe, here I'm saying that it's just a setter, but it's actually a function because it returns a subscription. So that kind of thing may be going on. But we kind of say that this is a setter because the main purpose of it is to pass these stuff, and sometimes you can ignore the subscription. But yeah, I don't think there is a primitive that is at the same time iterable and observable. That's a very good question. Yeah, not sure.
Something to think of maybe.
Yeah. There is another primitive called the async iterable, which you're basically, every time you pull a thing, it will give you like a promise. It's like you're pulling some async stuff, which is kind of like pulling an observable in that sense. If you sort of wave your hands many times and think that promises are observables. But the point being there is that you get something asynchronously. There's the async iterable, it might be that. Yeah. Any other question? There's one in the back.
Thanks.
Why? Okay.
We talked about getters,
Yeah.
setters. Are setter getters and getter setters, I think.
Yeah, I mean, I showed you, well, one of the complications is to talk about, are we talking about setter and getter, which is a function, or are we talking about setter of a getter?
Yeah, the latter.
Okay, setter of getter. I tried to come up with a good example of this. Probably it's a way of passing to another system. It's a way of writing a lazy value. You can think of it like that. Because getters are basically lazy values. Okay?
Is it useful to see things in terms of setters and getters? Because what we do all the time is translate it to something we know. So what is a setter? Oh, it translates to the other way around. Is it a useful abstraction?
I'd say it's an ubiquitous abstraction. So, like in cases like, you know, like the object that you just call it and you created this thing. Let's imagine that we didn't have object create. I think we didn't always have object.create. So we always had a way of making a fountain of objects. And if we don't like categorize that, I think it's like a missed opportunity. And one of the cool things is that if you think of a function as a getter and setter, right, that means that a function gives you laziness, flexibility, side effects, right? And you can put stuff into it. So it's actually, one of the ways you can think of functions is getters with parameters. So you have laziness, but it's like a parameterized laziness, right? So it's an interesting way of thinking like that, because often when we have functions, you know, they are, you know, they're just computations that will be lazily called.
Thanks.
Yeah.
That was the last question, or are there any more? Now I'm still walking.
You can also talk with me in person. It's totally normal.
Okay. Thank you.
Thank you.